Class 11th, Subject Physics, 10th Chapter Electrostatics. From the chapter, let us see the electric field intensity at a point on the axis of electric dipole. So, in this point, we have to obtain an expression for the electric field intensity at a point due to the electric field on the axis of electric dipole, and therefore let us consider an electric dipole consisting of two charges minus q and plus q situated at the points A and B respectively, so that this AB will produce an electric dipole. Let C be the center of the electric dipole, and therefore each charge, that is point A as well as point B, will lie at a distance equal to L, because the length of this electric dipole is equal to 2L. Now, in order to obtain the electric intensity at a point on the axis of electric dipole, let us consider a point P which lies on the axis of that electric dipole at a distance equal to R from the center of electric dipole, and therefore distance Cp is equal to R. Now, the electric field intensity at this point P will be due to the factor sum of the electric field intensities due to minus q charge and plus q charge, because due to this minus q charge some electric field will be produced at point P. Similarly, due to this plus q charge electric field will be produced at point P, and therefore the electric field intensity at point P will be equal to factor sum of the electric fields due to minus q and plus q charge. Now, from the geometry of figure, distance AP will be equal to this R plus this L, that is AP equal to R plus L, and BP will be equal to this R minus this L, so that we will get BP, and therefore these distances are written as AP equal to R plus L and BP equal to R minus L. Now, already we have studied that the electric field at any point due to a point charge q is given by the formula E equal to 1 upon 4 pi epsilon 0 q by r square. So, from this relation it is clear that as E is inversely proportional to r square, if distance of that point is close to the electric charge, at that time electric field will be large, and if this distance is large then electric field will be small, and therefore as electric field intensity at point P is due to both these electric charges minus q and plus q charges, therefore let us find these electric fields at first, and therefore the electric field intensity at point P due to the charge minus q situated at point A will be given as, by using this formula we have to find out factor EA. So, electric field intensity at point A will be equal to 1 upon 4 pi epsilon 0 minus q upon AP square into unit factor PD. But AP is equal to R plus L, and therefore we can write EA equal to 1 upon 4 pi epsilon 0 minus q upon R plus L whole square into unit factor PD, equation number 1. So, that PD is the unit factor along this line that is directed towards the charge or the electric dipole. This is for negative charge, that is minus q. Now, the electric field intensity at a point P again due to charge plus q which is situated at point B will be given as EB equal to factor EB equal to 1 upon 4 pi epsilon 0 q upon BP square, but BP is equal to R minus L, and into this unit factor PQ is there. So, that will be equal to 1 upon 4 pi epsilon 0 Q upon R minus L square. This is the value of Bp into unit vector PQ, equation number 2. Now for this positive charge PQ, which is directed away from the charge or away from the electric dipole, that will be the unit vector. Now if you consider this EA and EB, then magnitude of EB will be greater than magnitude of EA, since AP is greater than BP. Now this plus Q charge is close to this point P, therefore electric field EB due to this plus Q charge will be large as compared with EA, that is due to the negative charge, and therefore it is EB is greater than EA. Now the electric field intensity at point P due to the electric dipole will be equal to the sum of the electric fields due to these two charges, and therefore adding equation 1 and 2 we will get that electric field intensity at point P, and therefore we can write EP equal to EA plus EB in magnitude only. Here unit vectors are not considered because we are considering only the magnitude, equation number 3. Now putting values of EA and EB, we will get 1 upon 4 pi epsilon 0 minus Q upon R plus L square plus 1 upon 4 pi epsilon 0 Q upon R minus L whole square. Now taking common Q upon 4 pi epsilon 0. So Q upon 4 pi epsilon 0 is taken common. Then this positive term is written first and negative terms later, and therefore we will get 1 upon R minus L square minus 1 upon R plus L square, like this. Then that will be equal to Q upon 4 pi epsilon 0 into, taking cross multiplication we can write R plus L square minus R minus L square divided by, if you take the product of these two, then it will be R square minus L square whole square, because this is the expansion of similar to that of A square minus B square, that is equal to A plus B and A minus B, and its square is there, therefore it will be R square minus L square whole square. So that will be written as Q upon 4 pi epsilon 0, Q upon 4 pi epsilon 0 into, these two brackets will be expanded. So its expansion is R square plus 2RL plus L square. Then its expansion will be R square minus 2RL plus L square. But due to this negative sign, all these three signs of three terms will get changed, and therefore it will be minus R square plus 2RL minus L square. Now from this R square minus R square, L square minus L square will get cancelled, and 2RL plus 2RL we will get 4RL, and therefore further we can write Q upon 4 pi epsilon 0 into 4RL upon R square minus L square whole square. This can be written as Q upon 4 pi epsilon 0 into, this term is now splitted, as 4 is splitted as 2 into 2, and therefore 2 into 2RL upon R square minus L square whole square. So it will be, rearranging the terms will be written as 2 into Q into 2L into R upon 4 pi epsilon 0 R square minus L square whole square. But we know that this Q into 2L is equal to electric dipole moment P, and therefore EP will be written as EP equal to 1 upon 4 pi epsilon 0 1 upon 4 pi epsilon 0 into 2PR upon R square minus L square whole square, equation number 4. Now this electric field intensity at point P, that is EP, will be directed along PQ, that is away from the charges or away from the electric dipole. And then let us consider that if the distance of that point P, that is R, is very very large as compared with the half of the length of the electric dipole, that is if R is very large as compared with L, that means L will be very small as compared with R. And as L is very small as compared with R, L square will be neglected compared with the R square. So this L square from this relation will be now neglected, that means it will become 0 because L is very less, so its square will be again too small, therefore L square is neglected. Neglecting L square, we will get EP equal to 1 upon 4 pi epsilon 0 2pr upon r raised to 4. Here r square raised to 2 is there, therefore we will get r raised to 4. 1 r from this r raised to 4 will get cancelled with this r, and therefore EP, that is electric field intensity at that point P, will be given as 1 upon 4 pi epsilon 0 2p upon r cube, equation number 5. So this equation, that is EP equal to 1 upon 4 pi epsilon 0 2p upon r cube, will represent the equation for the electric field intensity at a point along the axis of that electric dipole.